Hey everybody, this is section 4.1. Sorry, there was a little delay. I couldn't get it unmuted. So in this section, this is sort of a different thing than chapter 3, what we've been working on, but what we're working on in 4.1 is divisibility. Okay, so we're talking about division, but really what we're going to talk about is how we know things are like how things are divisible by other numbers. This all falls under the category of number theory, and this is basically popularized by Pierre Fermat. Things like factors, multiples, divisibility tests, prime numbers, prime factorizations, greatest common divisor, least common multiple, all that kind of stuff. And that's basically what we're doing in chapter 4. This all starts to come up as kids move into multiplication, so like 4th grade-ish, pairs of numbers, that kinds of things. This is how you determine if a whole number in a certain range is a multiple or if it's a prime or composite numbers. That's part of what they do in those ages. We can also, as you get closer to middle school, you find greatest common factors and least common denominators. That's going to help kids as they move into thinking about fractions. Kids have to use factors, multiples, and primes to solve problems. This is what this all leads to, and this is a PA standard. So remember that when we're talking about all of this, right now we're still in integers. We're not into rational numbers just yet, but we are talking about the rules that apply here, generally speaking. Okay, so, well, and this is what gets us into rational numbers, because once we get to divisibility, we can start talking about fractions, which are made out of things that are divided. So there's a couple of definitions when we talk about divisibility. A number is divisible by a number A is divisible by B if A over B has no remainder. So it's divisible if there's nothing left over. You can divide anything into anything else, but if you have extra, they're not technically divisible. 12 is divisible by 3 because 12 divided by 3 is 4. There's nothing left over. There is another way to think about this and define it. You can say a number, sorry, my pen has not been cooperative the last few days. A number B divides A, written as B, so you read this as B divides A. If and only if there's a unique whole number Q, such that when you multiply by Q, you get A back. It's just like saying 4 divides 12 because 4 times 3 is 12. That's essentially what it's saying. Okay. B divides A means A divided by B has a remainder of 0. When they are not divisible, what you write is we say B is not divisible by A. Okay. If B divides A, B is a factor of A, and A is a multiple of B. So if we go back for a second, 4 divides 12. So 4 is a factor of 12. 12 is a multiple of 4. Okay? If your answer is a whole number when you do the division, then B divides A. Okay. For any whole numbers to add onto this, A and D, if D divides A, then N is any whole number. D also divides a multiple of A. What that says basically is if 4 goes into 12, 4 also goes into 2 times 12, which is 24, and it does. 4 also goes into 3 times 12. 4 also goes into 4 times 12 for as long as I want to keep that up. If D is a factor of 12 to start with, 4 is a factor of 12, then it's a factor of any multiple of 12 as well. If A and D are whole numbers, we have to determine the truth of what this says right here. So if A and D, let's see what the cases are. If 5 does not divide into A, and 5 does not divide into D, then 5 does not divide into A plus D. Well, let's see how that works. Let's give ourselves some examples. 5 doesn't divide into 6. 5 doesn't divide into 7. Does 5 divide into 6 plus 7? No. Okay, well, that's fair. But can you find a different case? Could we make this work out so that some part of this is untrue? Well, let's pick some other numbers. Let's do 5 doesn't divide into 7. And 5 also doesn't divide into 8. Well, does 5 divide into 7 plus 8? Well, 7 plus 8 is 15, isn't it? And it does. So this is not true. It's only true part of the time. So just because a number doesn't divide into 2 of the factors, when you add them together, it changes what's happening. Okay? So there are a couple of rules here. If a number goes into A and a number goes into B, it will also go into their sum. That's going to be true every time. If it divides into A and it does not divide into B, it will not go into their sum. It just means it's like off a little bit. It's like saying 5 divides into 10 and 5 divides into 15. Well, then for sure 5 divides into their sum, which is 25. But if 5 divides into 10 and 5 does not divide into 7, 5 also does not divide into 17. If D divides A and D divides B, and A is greater than B, which is the extra caveat here, then it works in subtraction. So if 5 divides into 15 and 5 divides into 10, then 5 also divides into 5. I subtracted them. Just like in case B, if it didn't work for one of them, it won't work for their difference. So if 5 divides into 15 and 5 doesn't divide into 7, then 5 does not divide into 8. And finally, if I reverse those things around for subtraction, because subtraction order matters, if it doesn't go into the first thing and it does go into the second, it's still not going to work out because it doesn't do both. So if I did 5 does not divide into 17, but 5 divides into 10, 5's still not going to divide into 7. Okay? All right. So we can go through and prove this. I think you believe me. We can keep trying it and trying it, but it's not really necessary to go through the whole thing here. What really matters in this section is right here. There are all these divisibility tests. They're lovely tools for you to have just as a human, as an adult, as a student. They're also lovely for your students to have to quick check if some small number is going to divide into a big one. It saves a lot of work if you use these well. So a number is divisible by 2 if it's even, basically. So I can do 42 divided by 2. This is any even number. A number is divisible by 3 if the sum of the digits is divisible by 3. So let's take a number. Let's take 621. 6 plus 2 is 8, plus 1 is 9. 9 is divisible. 3 divides into 9. So 3 also divides into 621. It's fabulous. For 4, we just look at the last 2 digits. The rest of the number, I don't care how many spaces it has, does not matter, okay? For 4, whatever is in the last 2 digits, as long as that is divisible by 4, the whole thing is. So here, 56 is divisible by 4. So 4 divides into 56. That means the whole number can be divisible by 4, no matter how big it is. The rule for 5 is something you've seen before. If a number ends in a 5 or a 0, it's divisible by 5. The rule for 6 is essentially that if a number is even and it's divisible by 3, it's also divisible by 6. Okay? So those are dependent. Okay, so this would be like 612 versus 621. 600, they both add up, the sum of their digits are 9, so they're both divisible by 3. But one of them is even, 612, so it's also divided by 6, or by 2, and one of them is odd. That one's even, that one's odd. So the only one that's divisible by 6 is the one that's both. So 6 divides into 612, but 6 does not divide into 621. Okay? There is no test for 7. I'm sorry to say, there just isn't. You gotta actually do the division there. For number 8, the number formed by the last 3 digits is divisible by 8. So 8 is a little different than 4, but it's the same idea. So if I take the number 1216 I want to look at the last 3 digits. If 216 is divisible by 8, then the whole thing is divisible by 8. So 8 does indeed go into 216. So that means 8 does also go into 1,216. That's how it works. For 9, the sum of the digits has to be divisible by 9. So let's take a number 4,302. I could do it, yeah, whatever. Or even we'll make it bigger. 94,302. So if we did 9 plus 4 plus 3 plus 0 plus 2, I would get 9 and 4 is 12, 13, 14, 15, 16, 17. Okay, so that's, I didn't add enough. That's 17. 17 is not divisible by 9. So that number is not divisible by 9. However, if I made that number and I added one more onto there, I would get 18. And 18 is divisible by 9. Okay, the sum of the digits have to be divisible by 9. For the last 2 rules here, if a number is divisible by 10, it ends in a 0 every single time. That rule hasn't changed. 11 is a little tricky, okay? Basically for 11, what it says is the sum of the digits in the places that are even powers of 10 minus the sum of the digits that are odd powers of 10 have to be divisible by 11. It's crazy. Okay, so let's see what that looks like. So if I have this number, 8,471,986. Basically what I do is I think about it by place. The first number all the way to the right in the ones place is considered an even place value. Okay, it's 10 to the 0. Technically, it's neither even or odd, but for this purpose, it is. This is 10 to the first. That's odd. This is 10 to the second. That's even. If you can't remember which one goes where, there's the place you figure it out. 10 to the third is odd. 10 to the 10 to the fourth is even, odd, even. We always subtract. Start with the even numbers, subtract away the odd. So I'm going to do 8 plus 7 plus 9 plus 6. And I'm going to subtract 4 plus 1 plus 8. All right, 8 plus 7 plus 9 plus 6 is something 15, 24, 30. Minus 4 plus 8 is 12, 13. Gets me 17. Is 17 divisible by 11? No. 17 is not divisible by 11, so the whole thing is not divisible by 11. That's how we figure it out. All right. So here is a ginormous number. What you have to do is tell me what it's divisible by. So take a minute and work through. All right. Pause the video. Try it. I'm going to make my little list of numbers here while you do that. Notice there is no 7 on the list here because I don't care about doing division right now. All I care about is that you know how these rules work. So is my giant number 57,729,364,583 divisible by 2? It is sure not, because it is not even. And you know what? Is it divisible by 3? Well, let's find out. I would add 5 plus 7 plus 7 plus 2 plus 9 plus 3 plus 6 plus 4 plus 8 plus 5 plus 3. That gives me a sum of 59. 59 is not divisible by 3. So no. Is it divisible by 4? Let's look at the last 2 numbers. 83 is not divisible by 4, so it's a no there. Does it end in a 5 or a 0? Nope, so it's not divisible by 5. It's not divisible by 6 because it's not divisible by 2 or 3, so that's a no. Let's see, 8. For 8, I'm dividing 583 divided by 8. You probably worked it out, and it is also not the case. Is it divisible by 9? Well, I already know the sum is 59. Is 59 divisible by 9? No. Okay. What about 10? Doesn't end in a 0, so that's a no. All right, and then we have to do 11 over here. So this is even, odd, even, odd, even, odd. All right, so I'm going to do, let's see, 5 plus 7 plus 9 plus 6 plus 5 plus 3. Okay, and then I'm going to subtract away 7 plus 2 plus 3 plus 4 plus 8. Okay, well, I'm going to get 35 for the first one, and the second one, 10, 24. 35 minus 24 is 11. Is 11 divisible by 11? Yes! So here, the only divisibility test that passes is the number 11. All right, so we can fill in the blanks. We can sort of do some work here to sort of mess around and make numbers divisible, okay? We want to take this number that we have here and we want to make it divisible by 9. Well, I want to fill it in as many ways as possible, so list all the possibilities. For something to be divisible by 9, excuse me, the sum of the digits has to add up to something divisible by 9. So I have to look at the sum of the digits I have to start. 1 plus 2 plus 5 plus 6 plus 5, 3, 8, 14, 19. So right now I have a sum of 19. What's this closest thing I can get to that is divisible by 9? Well, 9, 18, 27. So I want to get from 9 to 27 as the sum. I want the sum of the digits to be 27. So if I'm at 19, I need 8 more. Okay, well, so then let's see. I could put a 1 and a 7 in there. I could also put a 7 and a 1 in there. What else could I put in? I could put in a 4 and a 4. I could put in a 5 and a 3 and a 5. I could have put in a 2 and a 6 and a 6 and a 2. And I think that's it. So all of these are the possibilities to filling in that. Oh, I know I missed one. Do you know it? I missed 8 and 0 and 0 and 8, right? That would work too. All right, there is a game in here to play, but usually I'm not super worried. I think it might be in your written assignment. So there's one, what we do with this is we use it to help us in problem solving. So you have this class and they're visiting a neighborhood cannery because schools go on weird field trips. The warehouse manager says, class, there are 11,386 cans of juice in our inventory currently, and they're packed into boxes of 6 or 24. And one of the students went like, sir, that's not right. You have a mistake in your inventory. And the guy went, oh, no. But here's the thing, is the kid right? I don't know. How do we figure it out? Well, what do we need to think about? We know that there's cans, and they're packed into packages of 6, and then bigger packages of 24. 24 is a multiple of 6. So if this is divisible by 6, it's also 24, we'll see. So really in the end, I want to know if it's divisible by 6. Well, I want to know, to be divisible by 6, it's got to be divisible by 2 and by 3. So let's see, is it even? Yes. So it's divisible by 2 for sure. Divisible by 3 means we take the sum, and that sum of the digits is divisible by 3. So 1 plus 1 plus 3 plus 6 plus 8. Let's see, 2, 5, 11, 19. Oh, 19 is not divisible by 3, so that's not going to work. So he's right. You can't have this many cans and have them packed into boxes of 6 or 24 because, well, it's not divisible by 3, so it's not divisible by 6 because it has to be both of these to work. All right, this is the end of 4.1. I will see you in 4.2.